Good morning, guys. Today we are going to discuss a very important topic, actually, that is your load factor, right? And this topic is really important from your DGCA exams perspective. And not only that, but you will also come across this topic in your ground classes for your SPL, CPL, or PPL, right? So let's try to understand what really load factor is, right? So in the simplest term, we can say that it is the physical stress that actually acts on the aircraft while it is in flight, right? So there are certain forces that acts on the aircraft while it is in flight, right? So let me draw a diagram to explain it. So let's say this is my aircraft which is moving in this particular direction, right? This aircraft is moving in this direction. Now, just to keep this aircraft in the air, there will be certain forces that will be acting on it, right? So for any object that is in the air, that is above the ground, there is one force that naturally acts on it, right? That is weight. So the weight is acting on this aircraft downwards, right? Now, since it is flying, it is in the air, there has to be another force that is actually equal and opposite to keep it right there, or roughly equal and opposite. That is lift. So weight, this is a kind of downward acting force, and this is upward acting force. Now why I have written the word force, I'll explain in some time. So basically there will be two more forces that will be acting. So it is moving in this particular direction. There is certain direction for this aircraft. So for this aircraft to move, there is this force called thrust, right? So thrust is that push that will make the aircraft move in a certain direction. Now while this aircraft is moving, there will be some other force that will be acting opposite to this thrust, the retarding force that will try to pull this aircraft back, right? So that force will be drag, right? So these are the forces that acts on an aircraft, right? These are the four major forces actually acting on the aircraft. Now we were discussing about load factor, right? So to understand load factor, we are interested in specifically two things. One is our lift, the other is weight, right? So load factor is nothing but your lift upon weight, right? Correct? So lift upon weight. Now lift is a kind of force, as I said earlier, and weight is also a kind of force acting. Lift is acting upward, right? And the weight is acting downwards. So there are two forces. Force cancels out. Therefore load factor is a dimensionless quantity, right? Always remember this. So load factor is not going to have any units, right? It's a dimensionless quantity. Now when an aircraft is flying straight and level, basically, so it is not banking, it is not making any turns, it is just going straight, right? So what happens to the load factor? Here it is, right? This aircraft is going straight, it is not banking. So basically the lift that is acting upwards and the weight that is acting downwards, they are roughly the same, right? Roughly we can say that they are approximately same. So in a level flight, when we write lift upon weight, So lift and weight are almost equal, so they will cancel out each other, giving load factor of 1. So this thing you will come across in your exams, like there would be questions that in a straight and level flight the value of load factor will be, there will be 3 options, right? Your DGCA exam has ABC 3 options, correct? Or vice versa, that the load factor is 1. So what can you tell about the lift and the weight acting on it, or what can you tell about the kind of flight? Basically, there will be 3 options, right? Now after this there is another important thing. Now this was about, you know, straight and level. What if the aircraft is banking, right? The aircraft was flying straight and then it started turning and it has made an angle with the horizon, right? What happens in that case? So let's say this is another aircraft of mine and now it has started banking, correct? So here again the weight will be acting downwards, correct? And the lift is always going to be in this direction, correct? So it is always perpendicular to the body of this aircraft, right? Now how do you balance this out, right? So there will be another force that will be acting horizontally here, right? That is our centrifugal force, correct? The weight acting downwards and the centrifugal force acting horizontally, correct? Now this is again an important thing which is sometimes asked, that when an aircraft is banking, what are the type of forces acting on it, right? So the forces, the weight is acting downwards and your centrifugal force is actually acting horizontally, correct? And the resultant of these two, basically your centrifugal force and weight, is your load factor. So this is your load factor now. So first formula for load factor. So guys, I am going to write load factor as LF. So that was lift upon weight. Correct? Now another formula for load factor is 1 by cos theta, which is secant theta, where theta is your angle that your aircraft is actually making with the horizon, correct? So what I really mean by this is, so we'll take the previous example, that this is our aircraft. Now it is banking. This is my horizon. And now here it is making some angle, right? Let's say this is 60 degrees. This aircraft is making some angle with the horizon, and that angle for now, let's say it is 60 degree, correct? So what is going to be the load factor for this? Now here we need to remember a couple of things, right? So I'm not sure like if everybody remembers the sine theta and cos theta. Just how much? 1 by 2, 1 by root 2, root 3 by 2 and 1. And cos theta, will be the reverse of it, 1 root 3 by 2, 1 by root 2, 1 by 2, and this is 0, right? So the reason I have written this down is because some of you might not be remembering, so it will be easier for you to refer this, right? So what happens here is our theta is 60 degree, right? As I said, 1 by cos theta. So load factor here will be 1 by cos 60. Now what is 1 by cos 60? What is the value of cos 60? Cos 60 is 1 by 2, right? This goes up, this becomes 2. So for an angle of 60 degree, the value of load factor is going to be 2. Now this is a number, and I said earlier that this is dimensionless, right? I mean, there are no units to it. But how do we understand like what is happening here? Like, you know, if I have to tell somebody, if I have to make a comparison, that what does this 2 means, right? What does this 2 means for the aircraft actually? So let's try to understand this from a simple example. So all of us on the surface of the earth experience some kind of force on our body, right? And that force is equal to 1g, right? So I'll write it as 1g, right? G here is number of times of gravity, right? So this is not to be confused with capital G, that is your universal gravitational constant. This is not that, right? And this is not small g, that is your acceleration due to gravity. For simple sake of understanding, try to assume that this is, you know, the number of times that you experience the gravity on the surface of the earth. So what I really mean by 2 here is, when I write 2g, it means 2 times the gravity on the earth, right? So when I say 2g, it is 2 times the gravity that aircraft would experience on the surface of the earth, right? Or in a straight and level flight. So it similarly 3g would be 3 times of that gravity basically, right? Now as I said, like there is this theta, right? We discussed 2 formulas, that is your lift upon weight, and then your 1 upon cos theta, that is your secant theta. So there might be a question in the paper that would say like, what are the factors that impact your load factor, right? So we just saw one of them, which is your bank angle, right? So bank angle impacts your load factor. Now how it behaves with the bank angle? So let's take another example where theta is equal to 45 degrees, right? So what happens? 1 by cos 45, 1 upon 1 by root 2, this becomes root 2. Root 2, for root 2 value would be 1.414, right? This is smaller than 2. So for 45 degree, this is for 45 degree, this is for 60 degree. So we can say that the load factor is directly proportional to your bank angle, correct? From the example that we saw, that as we are increasing the value of theta, or that is your bank angle, your load factor is increasing, correct? Now in this particular diagram, we also saw something called centrifugal force. Let me erase this actually. So earlier I made this aircraft which is banking, and I said there are 2 forces acting. One was my weight, the other was my centrifugal force. right? Now what happens to the centrifugal force, right? So when we increase the speed of the aircraft, so let's say the aircraft is banking and we increase the speed, right? So what happens here is, when we increase the speed, the centrifugal force really becomes difficult to overcome, which in turn means that as we increase the speed, the load factor increases. All right, so load factor directly proportional to speed, and the load factor is your load factor directly proportional to your bank angle. I should write it the other way. Load factor directly proportional to your bank angle, and load factor directly proportional to your speed. This is an important thing to remember, right? Now, what happens if we increase the load factor? What is the impact of this load factor? Basically, we have studied, like, you know, if the aircraft is banking, if the bank angle increases, the load factor increases. But what really happens if this load factor increases? So basically, there is something called stall speed, right? So that is the speed. Below that speed, the aircraft is going to lose its lift, right? And it's going to come down. So if we increase the load factor, this stall speed increases. Right? What I mean by this is, let's say an aircraft initially could have stalled at let's say 90 knots. Now I'm just taking this for the sake of example. This is not a real value. So let's say earlier it could have stalled at 90 knots, right? Now when the load factor increases, it would stall at 100 knots, right? So what is happening here? The stall speed has increased. And why it is important to understand? Because if the stall speed increases, even if you are actually having a higher speed, there are chances that you will hit this number very easily, right? The increased stall speed for that aircraft, you are going to hit that very easily, and then eventually you are going to lose lift, right? So that is how it becomes really important. Okay, there is another important thing, that is limit load factor. So this is nothing but it is the maximum limit to which, this is the maximum limit of your load factor, right, to which an aircraft is designed to operate, right? Now we'll see what are the limits. So there are different categories of the aircraft and they have some defined limits. So there are 5 broad categories. Say 1, 2, 3, 4, 5. The first one is transport. The second is normal. Third is utility. Fourth one is aerobatic, and the fifth one is helicopter. Now each one of them will have a lower limit and an upper limit, right? So for transport it is -1 to 2.5 g, and again this g is the number of times. -1.52 to 3.8, -1.76 to 4.4, -3.0 to 6.0, and this is -1 to 3.5 g, right? Now these numbers are important from the exam perspective. So these values, basically the upper limits specifically, you will see this very frequently in your DGCA paper, right? The DGCA paper for your technical general, you will see this upper limit being asked, and specifically for like normal and utility category, you will see this very often, right? So nothing fancy in it, like these are just numbers we need to remember. So since we have discussed the topic, let's take one or two examples of like how the questions are being framed in the question paper for your technical general. So they might ask something like this, that an aircraft, so guys I am writing aircraft as A/C. So an aircraft making an angle of 60 degrees, right, with the horizon. The load factor will be and you have three options, right? So A, B and C. First is your 1, 1.4, 2, right? And we saw that earlier, right? For 60 degree, the value is going to be 2. Or the other way around, they might give you that the load factor is 2, right? What is the angle that aircraft is banking at, right? So how do you do that? So 1 by cos theta is given 2, right? We inverse this. Cos theta equal to 1 by 2. And what value of cos theta is 1 by 2? That is your 60 degree. So theta is your 60 degree, that is your bank angle, right? So these are the type of questions they are going to ask, and also like the chart I had shown you like earlier for the limit load factor. So those are 3 or 4 questions. They are, I mean, out of those 3 or 4 questions, they might going to ask you like 1 or 2. So I believe like I have covered most of the things, but if you feel like if I have missed on something, please feel free to share your comments and we'll try to cover it in our next lecture, right? So thank you so much guys. Have a good day.